So continuing to look at organic textures, we're going to go ahead and create a dirt texture in this video. And we're going to be using some rasterization techniques where we take geometry from the SOP level and use it in COPs. So just to show you an alternative workflow to the previous video, we're actually not going to be doing this at the SOP level. We can go over to the stage level directly, and let's begin with a geometry. So we're going to use a SOP create over here just to create a geometry to apply a texture to. This can be whatever you want. For me, I'm going to use a sphere, and let's apply some UVs to it. We can use a UV project, and instead of using a projection of orthographic, we'll use polar, initialize, and there we now have some UVs. We can now go up a level and rename this to sphere, and let's also go ahead and apply a material to it. So we're going to go ahead and just use a quick material over here, so quick surface material, rename this material to something else. We can rename it to dirt, or rather dirt material. Now to assign this material, we can simply use an assign material. Firstly, as a primitive, we're going to grab our sphere, and secondly, as a material path, we're going to grab materials, dirt material. Right, so if we now change the color over here, you can see that it affects our sphere. So we have this material applied, but we don't really have anything working in terms of color maps or displacement or any of the things that we really want. So over here, we're going to go to the base and set or create a color map. It's going to set this to a UV gray grid. And so we don't want to be using this, but rather a cop net that we're going to be creating. So go over here to the right, where we have this option to create cop texture for this map. And all we have to do is click on that. And over here on the right hand side, it'll create a dirt material maps network. And this will contain all of the different maps that we're trying to create. You'll see that it applies this default one to our sphere. And if we dive inside of our cop network, this is all that it's doing. Now it is creating a reference to this base color over here. If we go up a level, you'll see that this is creating a path to /stage /dirt material maps /base color. So that is what it's looking for, this base color null. So anything that we plug in to base color null, it's going to fetch it for our base color. Now we can do the same over here for specular. We can go over here, and instead of a color map, we want a roughness map. Once again, clicking this, you'll see that it doesn't actually add a new network. All that it does is it adds a separate one down here. So now we have two nulls. This one is our base color, and this one down here is our specular roughness. Again, we can go back and under bump height map, or alternatively, you can use the bump normal map. Clicking over here, this will once again add one last set. So we now also have a bump map. So now we have the three nulls, and all of them are actually linked to this over here. So if we make changes to any of these three nulls, then they'll reflect on our sphere. So let's go ahead and actually start adjusting our sphere. The first thing that we want is to create the basis for our dirt texture. And so we're going to start quite simply with this by just doing some noise patterns. So over here, I'm going to make some space, bringing my base color up to the top, and we can use a noise. So we're going to use a fractal noise to begin with. And this fractal noise can already replace the checkerboard that we have, right? So this is our new base color. As for this fractal noise, let's go ahead and increase the roughness on it, give it a bit of an offset, and that's all we really need right now. The next thing that we're going to do is take another fractal noise, and this one is just going to apply some sort of cracks or interesting crevices into our ground. So we're going to be using Wally Cellular. You can use either one of them. So F1 is fine, or we can use F2 minus F1, reducing the roughness slightly, increasing the element size, and then reducing the center slightly. We're really mostly interested in these dark areas, and so we can then use a minimum and find the minimum between our fractal noises. Now, what you'll find is that it's only fetching this top one because these values are all generally lower than the one below. So what we need to do is use a remap so that we're only getting the dark areas over here. So to do that, we can simply drag over the high end of this ramp so that we only have those dark areas, and then that'll be applied in our minimum. The other thing that we can do over here is increase the output minimum so that it's not completely black, right? Something like that. And what we can do is we can also reduce the amount so that it blends in a bit more naturally. And then of course, just keep playing around with these settings. Okay, so this is going to be our foundation, right? And because we're working in this sort of setup, it would help to make our lives a bit easier by naming things or putting things into subnets or any variety of things to improve our workflow. So one thing we can do is put this into a comment box over here. So click and drag over these nodes, and in the top right, we can create a network box, and we can just call this network box dirt basic. So that's just going to be the basic setup for our dirt. So let's also consider how we can get this to a more interesting color. So we can just go over here and use a ramp. So ramp RGB, plug this in to the position, plug that into the output. And over here, we can just give this some dirt-like colors, bringing up the low end. So something like that looks decent. But once again, we can also use ambient occlusion. It's just a really nice way of getting some good detail in. So height to ambient occlusion once more. Plug this in over here. And let's take a look at what we have. Increase the height scale to get some of that detail in. And that can rather go into our ramp over here. And then we'll just need to make some adjustments to the positions. You can also change the view radius and the step scale. So something like that already looks pretty good. So that's going to be our base color. But it's pretty nice to also take what we already have over here and just plug that into our height. We can also just plug this into our height down here. So let's also set up our roughness in a very basic way for now. All we're going to do is use a remap, and this remap we can just flip so that the low-lying areas are rougher, and then increase the output minimum. We want this to be quite diffused. So we plug this in over here to our specular roughness, jump up a level, once again setting the roughness over here to 1, so it acts as a multiplier for our roughness map. And the other thing that we're going to do is just go down here to our bump and increase the bump scale, and also make this a true displacement, right? So it's going to look a bit messy right now, but we are going to adjust the dicing, and we can also subdivide our sphere. So for now, I'm just going to subdivide our sphere. So we can put a subdivide, set it to 4, jump up a level, and we have more detail to work with. So I'm going to reduce the bump scale to 0.05, maybe even lower, 0.03. I also don't like how shiny some of these areas are. So over here, under our roughness, we're going to increase the output minimum for our remap. Cool, so now we have the start of a decent dirt texture. The only other things that I'm going to add are just going to be so that it's easy for us to visualize this as we're working. So that's going to be a camera, just positioned over here, and a calmer physical sky right over here. And there we go, right? So it's already looking decent, but now we're going to have to take a look at rasterization. And this is where it's going to get really interesting in terms of adding our own flair and detail to this dirt texture. So back inside of our cop network is where we're going to start doing that. All right. To begin with rasterization, we're going to create a SOP network that we can then use to scatter points, and then we can take those points and rasterize the geometry that we create with them. So let's go ahead and just create a SOP import. And the SOP import node can actually use an external SOP, so you can find a SOP that you've already created, or alternatively, we can dive inside of this one. I'm just going to rename this to stone points, and inside of here, we're going to begin creating some points. So let's go ahead and just create a grid. This grid we can set up on the XY plane, right? So it's the same as our cop network. And then we can go ahead and change the size of this to 2 by 2. Now, you might be wondering why not 1 by 1. And the reason I wanted it as 2 by 2 is simply because of this over here. If we take a look at our cop network, the ranges of our values inside of our cop network actually range from -1 to 1. What do I mean by this? Well, if we go over to our composite view, and we take a look at the bottom left and top right, you'll see that we have -1, -1, and 1, 1. This is our coordinate space, right? So it goes from -1 on X and -1 on Y, all the way up to 1 on X and 1 on Y, which means that we have a total length of 2, right? From -1 to 1. So when we create this grid over here, by making it a 2 by 2 on the XY plane, it's fitted perfectly to that particular cop network. So let's go ahead and scatter, and now we just have some points. And with the scatter, we're going to copy to points. So copy to points right over here. These are our target points to copy to. And what we're going to copy are just these spheres. The sphere over here, we can set to a polygon and then use an attribute noise. We're going to just rough this up a bit. So set the vector value to P. That's the attribute that we're adjusting. And instead of doing a range value of positive, we'll do 0 centered, reducing the amplitude, reducing the element size, just until we have an interesting shape, something like that. Now we can copy this to all of these points, and right now it's not going to look great, and that's because we don't have any attributes set up on our scatter points. Now there are a bunch of ways of doing this. You can use attribute creates. I find the easiest way for me is just an attribute wrangle. You can also use attribute randomizers or noises, whatever you want. I'm just going to use an attribute wrangle. All I'm going to type is @pscale equals random, and we're going to generate a random p-scale per point. So we're going to say @pt_num. So I'll zoom in over here so you can see what I'm doing. So each one of these now has a random scale. We're also going to multiply that by 0.01 or a little bit more, 0.05. Right, so now we have all of these little pebbles, but they all have the same orientation. So that's the next thing that we want to fix. we want to say p at orient. So this is a vector 4, and we're going to make this equal to random at pt_num. And because we don't want the same seed, we're just going to say comma and then add some value to here, and that will add some variation, right? So they all have different orientations now. Now this is pretty much done, but I'm going to show you some of the errors that this has and some of the ways to fix it. So let's go up a level. And what you have over here are these points, right? So the sub import now contains all of these little pieces of geometry, and we now need to convert this into something that our COP network can actually use. To do that, we're going to use the Rasterize setup. This prepares us for rasterizing these points. So we plug this in over here, and you won't see any difference. The next thing that we're going to use is the rasterized geometry. So rasterized geometry, plug the result into the geometry, and there we go. Right, so now it's converted it to a bunch of alphas. We have more than just that as an option, and the one that we actually want to use is the position. So go to quick setups and say add position. It'll take the P attribute and set this as RGB, so all of these have different position values. Now we're only interested in the Z depth, so what we can do is we can use a channel split. You'll see over here that P is an RGB value, so plug that in over here, and we can now split these out. Blue is going to be the Z value. And if you want to view a particular output over here, you can actually click on the bottom right over here and change what you're viewing. So if I set this to blue, you can actually see that this is what I'm interested in. So I'm going to take this blue value. This is going to be our Z depth. And this is just useful because it's going to be an indicator of how far away from the surface a particular stone is, or more importantly, its height. So we're going to grab this blue value over here, and we're going to equalize it. All this is going to do is bring it into a better range for us to work with. And now you can see that we actually have the height values of all of these. Now we do have this sort of graying, and a good way to actually set this is scale to maximum length. So equalize by scale to maximum length. And this is going to give us a slightly better result to work with, where black is going to be the lowest areas, and then white is going to be the highest areas. Now this is cool because we can use this in all sorts of ways. We can feed this in and do all sorts of adjustments, right? We can very easily now just merge this in with a maximum operation, and we'll have a decent looking result. The problem, however, is that this is not tilable. So if we take a look at this and use a transform node, so right over here, and then we scale this down. So uniform scale, bring this down, you'll see that this is actually not seamless. There's a line that runs through here, and our stones are being cut off. So we need to find a workaround for that, because this part over here, where we have our base color, that is seamless. And that's because we generated it using only noises. But this one over here is going to give us some problems. So to fix this, we can go over here to our stone points, and we're going to make a few adjustments. The first thing we're going to do is we're going to adjust the size of our grid. We're going to make this a 1x1 because we're going to be copying it over and creating our own sort of tiling. So we scatter our points, and then we apply a p-scale and an orient based on these random point numbers. Now, once we have that, let's go ahead and actually tile these points. So we're going to be doing tiling in SOPs. The way we're going to do that is by using a copy transform right over here. We're going to set the total number to 3, translate it 1 on the X. That's going to give us these 3 panels. We're then going to duplicate that copy. And instead of doing X, we're going to be doing it on Y. That gives us this, where we have these 9 tiles. And then we're going to use a transform node. So with this transform node, we're going to move this -1 and -1. So on X and Y, and that's going to bring us back to the origin. So just to go over that again, we have a grid with a size of 1x1. We scatter points, we apply random p-scales and orients, we copy and transform them 3 times across and 3 times up, each by a unit of 1, and then transform it back down. And because we've now tiled it in this manner, there's replication occurring at the edges. And so when we do our copy to points over here, and then go up a level, we can then use that transform node and see what we have. So we'll transform, scaling it down. And if we zoom in, there'll be no seam, right? So we've now made this seamless. We, of course, maybe have too many points and all of that, but that's not really a problem. We can just go back in here and adjust our points. So I'm going to reduce this to something like 100. And then it's also changed the range of the sizes over here. And that's very simple. All we have to do is wrap this random over here in a channel ramp function. We'll call this scale distrib or distribution, comma, rand at pt_num, right? So we're now doing a ramp distribution for the random value that's generated over here. And then all we have to do is create our spare parameters. And we can make it so that most points are smaller, but some points are bigger. Then we can change the general multiplier for that, just something like this. Now we have this and it's still seamless. So now we can go back to working with this as we originally were. We now know that this tiles perfectly because we did that little setup in our SOP import. So let's go ahead, and before we do this whole height to ambient occlusion thing, let's introduce this into the rest of our dirt stuff over here. So we have this dirt basic, and you can see that it's being used by 3 different outputs. What we can do is use a null, plug this in over here, and then reconnect these up, right? So that's just a little bit cleaner, and we can just call this dirt. And a nice thing to do is to also just rename our outputs. So you can see over here that this input coming in has an output. We can rename this to something like dirt, because that's just our basic dirt. And now let's bring all of this that we have over here down and plug it into the second input. Then we can rename that second input to something like stones, right? Now it's really nice because we have 2 outputs coming from the single null. And again, over here, we can just add this comment box. And we now have our dirt up there and our stones down here. And now let's go ahead and combine them, because this null over here, remember, isn't doing anything. It's just a rerouting option that we have. So now let's consider how we can integrate our stones into our dirt. So first thing that we want to do is add some variation to these stones, because we can actually see that there is some repetition going on. And it would be nice to actually just adjust this with a noise pattern. So we can use a fractal noise and a multiply, multiplying these 2 together and then pushing up the amplitude of our fractal noise. That's just going to add some fine detail. We can also increase the roughness of this so that our stones aren't as smooth. So that already looks pretty good. I also don't like how sharp these stones are, and that's going to be dependent on these stones over here, the attribute noise. We can just reduce the amplitude so that they're a little bit smoother, something like that. So I prefer the way that that looks. And now we have both of these over here. We can take a look. We have dirt and we have stones. And now let's bring them together. So the easiest way to do this will be with a maximum operation, where we're taking the dirt and the stones, and it doesn't matter which one is in which input, but what does matter is the brightness of our dirt layer, because if it's too bright, then none of these stones will be showing through, because maximum will only choose the brighter of the 2. So we can use a multiply constant, plugging that into the dirt, and over here, all we have to do is reduce the brightness. So we can drop that brightness until our stones start showing through, something like that. So that looks pretty decent. Now, the only other thing is that if we plug this into our height to ambient occlusion and then into the ramp, we really lose the stones, right? Because the ambient occlusion doesn't really maintain where those stones are. So something that may be better to do is to rather just use our ambient occlusion for detail, but mostly rely on this for our color. So to do that, we can once again just use a blend, and we'll decide on the operation afterwards. So we'll take this over here and our ambient occlusion, and we'll blend them together. So let's try a multiply and then reduce the mask value, something like that. And that looks pretty good to me. So we can now take that and put that into our ramp. And now on this ramp, our stones are going to occur on the higher end. So we can add a lighter color for our stones up on the higher end. So something like that. If you want the stones to stand out even more, you can take this one over here where we have the multiply, and you can make adjustments with it, feeding it directly in over here. For example, we can use another blend mode over here, straight after our ramp, bringing in these stone values. And then all we have to do is perhaps something like a screen and then reduce the amount, right? So that can brighten up our stones very slightly and make them a bit more distinct. So once we have all of this completed, let's just make sure that we're also plugging in our roughness and our height. So we're going to take this over here where we have the maximum, and we're going to plug that into our bump height and into the remap for our specular roughness. Jump up a level and let's see what we have. And that's looking decent. The only thing is our sphere has some stretched UVs. So we can use a UV transform. We'll increase the scale slightly on X, and then also increase the general scale. Go up a level, and there we go. Now we're getting a good idea of what our dirt texture actually looks like. Remember, if you don't like such bumpiness in those rocks, it's very easy to fix. All you have to do is change the fractal noise that's being multiplied with our rocks over here. So decreasing its amplitude, something like that, will give us slightly smoother rocks. The last thing that I want to show you is how we can get custom colors per each one of these rocks. The way we're going to do this is by going into our stone points over here and adding an attribute to rasterize. Just like how we rasterized our P attribute over here, we can rasterize other attributes. So we go over here, and in our attribute wrangle, let's add one more line of code. And the line of code that we're going to add is just I at ID equals at PT num. This is just adding an ID attribute, And we're doing it before all of our copies so that some points actually share ID attributes. This just ensures that our tiling still works. So we go up a level, we rasterize geo, and then we just add one over here. The one that we want is going to be ID, and as soon as we enter that, it's going to throw an error. That's because ID is expecting an output type of ID. Now on here, we can actually see our IDs right over there, and we can do all sorts of things with it from here. So if I take this ID now and use a random mono, and then plug our IDs into the seed value, you'll see that it generates a random value depending on the ID. We can also change the seed until we have something that we like. Now we can just use a ramp RGB, so ramp RGB right over here, put that into position. So just to really get an idea of this, let's use infrared. So we end up with a wide range of colors, and then we can take this and multiply it up here. So we'll use a multiply, and then we'll bring in that color. And you'll see that each one of our rocks now has some color variation. The issue is that it's also applying it to our actual dirt. So you'll see that the dirt has changed color as well. And we can avoid this by using a mask. Now the thing that we'll want to use as a mask is probably this over here, because we have black and white variation. So we can drag this into the mask, and now it'll only apply those colors to the white areas of our mask. So that really narrows in where this is being applied. Now, of course, there are other ways of using a mask. For example, we can even take from the equalize over here, or we can even remap this range. So if we give a remap over here, what we can do is make sure that we don't have any gray areas, because that will be treated as a mask with a medium opacity. So reduce the input max and then plug that into our mask, and it'll be more precise, right? So it'll be wrapped very tightly around each one of these stones. And of course, you still have the option to adjust how much this actually affects our geometry, but that's it, right? If we go up a level, we have this weird looking Christmas dirt. So you can make all sorts of changes, changing the colors over here to something that's a bit more reasonable. And that looks pretty good. The only other things that I would consider changing is our dicing. So once again, render geometry settings, affecting our particular primitive, that's sphere, scrolling down to dicing, set or create, setting dicing up to 1, that gives us more detail, and then playing around with all of these values that we have. There we go. And this can now be applied to any geometry, just as we've seen before. So we can drop a rubber toy, plug that into our UV transform, set this to a value of about 4, and let's see what we have. So now we've got a really good looking dirt texture. It's seamless and tilable, and we have complete control over this. And you can very easily go ahead and duplicate this network over here, do the same thing for twigs. So I hope that this video helped you understand how we can go about rasterizing geometry so that we can get certain attributes off of it, and then converting it into something to be used inside of cops. In the next video, we're looking at how to create grass, and the intention behind that video is showing you how to, instead of rasterizing geometry, actually stamp points. So all we're doing there is copying images to each one of those points. So we'll be doing that in the next part, and that's going to be a little bit more advanced. So I hope you're finding this useful. I'll see you in the next video.